So today we'll look into chapter 3 of Boolean Algebra and Digital Logic. So this is in your Computer Organization and Architecture book. Some of this you should have covered in your foundations too, and discrete math. So this is a simple truth table. So zeros are false, so false and false will give you false. False and true will give you false. So 0 is false, 1 is true. True and false will give you false. True and true will give you true. So this is the OR. So 0 or 0 is 0, 0 or 1. So false or true is true, true or false is true, true or true is true. So these are, let me see, I skipped. So this is for not, so negation. So the negation of 0 is 1, the negation of 1 is 0, and so forth. So these are more formula oriented. So you basically plug in the formula and find the output. These are different laws. You got the identity law, null law, idempotent law, inverse law, commutative law, associative law, distributive law, absorption law, De Morgan's law, and double complements law. So these are truth tables for the De Morgan's law. So again, notice these, how they're done. So this is, we can do one. So this is X and Y. So X and Y, so 0 and 0, or false and false is 0, and you negate that and you get 1 here. So these are done the similar way. These truth tables are representative. So this is an AND gate. This is an OR gate. This is a NOT gate. This represents a negation here. So this is an XOR. And the truth table is representative here. So you got the truth table. This is the truth table in symbolic logic for NAND. Truth table for NOR. So these are circuits that are constructed in an AND. 3 input OR gate. So this or this or this. 3 input AND gates. Remember, see the Y is negated here. 2 inputs and 2 outputs. So this is a logic diagram for this formula here. Line drawing showing a circuit. So this gets into a more of an SSI integrated circuit combining what we have discussed above. So this is the line drawing showing a function that evaluates one AND gate using X and Y input. So this is the truth table for a half adder. So these are the inputs and the outputs with the carry. So these are the logic diagrams. It gets into more of the logic diagrams. So ripple carry adder, decoder, multiplexer, and the symbols. Parity bit. Again, more into the parity bits here. Shift, 4-bit shifter. So it gets into the more complex diagrams here. Clock signal, feedback, flip-flop logic. So these are different logic circuits. Again, the truth table for SR flip-flop, it goes back into the concept we learned earlier. Different, JK flip-flop, JK characteristic table, JK flip-flop as modified SR flip-flop. So timing diagram for JK flip-flop. More diagrams into the Moore machine. So condition algorithm state machines. So this goes into the state machines as well. So JK flip-flop, these are into the more complex diagram. If you go through the book, it should help you understand. If you have any questions, you can post them, especially the state diagram. So again, this goes into the truth table. Remember, these are negations, so whatever x is, it's going to be negated. Same thing here. K-map. So grouping of items. So go through your book. Let me know if you have any questions. You can post your questions on Teams as well.